Hi, welcome to today's tutorial. I will show you how to calculate linear regression in Excel, create a chart showing the trend line, and interpret the results. I'll be using two variables, the X variable, which is the explanatory variable, age, and the Y variable, price. We'll use a scatter plot, which requires two variables. Highlight both variables and click on the Insert tab to choose the scatter plot chart. You can change the axis labels and go to Quick Chart Layouts to select the chart that includes a trend line and the equation. To reduce the spaces on the extreme left of the x-axis, double-click the labels and the Format Axis options will appear. In the Axis options, insert your preferred number to minimize the empty spaces. Bold your equation and format the trend line. By choosing a bright color and increasing the width to make it stand out. The equation displays the slope and intercept of the data, as well as the r-squared value, which we will confirm with our regression analysis. Now, to analyze simple linear regression, we have customer data showing their age and the amount spent on groceries. We will determine the values of r-squared, intercept, alpha, slope, beta, and the p-values of alpha and beta, which are often used for hypothesis testing. The first step is to go to the Data tab, click on Data Analysis, and in the Data Analysis dialog box, select Regression, and click OK. Here, we will input the Y range. Select the Y variable, which is the dependent variable, in this case, the price of the goods. Next, input the X range, which is the age of the customers, the independent variable. This should be selected along with the headings, so be sure to check the box that says Labels. The next step is to specify the output option. We can either display the output results in the same Excel sheet or in a new worksheet. We will choose a new worksheet and name it Regression Result. Click OK, and the summary output of our regression will appear in the new worksheet. This is how we calculate simple linear regression, and here's how to interpret the output. First, examine the r-squared, coefficients, standard error, and p-value. This will be color-coded to help us identify what I will explain. The first item to interpret is r-squared. R-squared ranges from 0 to 1, and a higher r-squared suggests that the model fits the data well and can make more accurate predictions. Our r-squared is 0.69, indicating that about 69% of the variation in price is explained by the age of the respondent, meaning that the model is a good fit. Next, interpret the p-value associated with the F statistic. This value is 0.000, which is less than 0.05, indicating that the model is statistically significant and suitable for predicting the outcome variable. Next, we look at the intercept, alpha, and the slope, beta. We can frame the regression equation in the format y equals alpha plus beta x. In our case, alpha is negative 64.26 and beta is 4.42, giving us the regression equation y equals negative 64.26 plus 4.42x. The interpretation of this equation is as follows. There is evidence that x contributes to predicting y. Specifically, the value of beta, 4.42, suggests that for every additional year of age, the amount spent on groceries increases by $4.42. This means that the age of the customers and the price of groceries purchased are positively related. As age increases, the amount spent on groceries tends to increase. This concludes today's tutorial. Subscribe for more analytical tips.